Hello and welcome to video number 3 in this series on waves. In this video we are going to focus on the frequency of a wave. We're going to look at what frequency is. We're going to look at how to identify the frequency of a wave from a frozen wave diagram. We're going to look at what the units of frequency are, and we're going to dive a little bit deeper and we're going to explore the relationship between frequency and wavelength of a wave. So before we start, it's really important that we recall the key information that we have covered so far. So I'm going to pop a retrieval grid on the screen now, and what I'd like you to do is pause that, answer those questions the best you can, and then unpause the video and the answers will be revealed to you. Okay, so let's get started. So the first thing I said I was going to talk about is what is the definition of frequency. So frequency is the number, let's go right now, of waves per second. Okay, so frequency is the number of waves per second. It's the number of waves passing a point per second. So I've drawn this frozen wave diagram here. And I'm going to put on the 0, so that's the line of zero disturbance which runs all the way from the middle, and remember this arrow represents the energy is being transferred, and this is a transverse wave. These are the peaks, these are the troughs. This is the positive direction, so when because the thing that we are oscillating is moving forwards and backwards, so we've got the positive when it's moving in the forward direction, and we've got the negative when it's moving in the backwards direction, or the opposite direction. So in order to figure out how many waves there are per second, we have to take our wave diagram and you have to be able to identify one wave cycle. And one wave cycle equals one wavelength, which remember that symbol there, lambda, represents wavelength. So we've got to find a wave cycle, and the way you'd find one wave cycle is to find one wavelength. So in the last video, we looked at identifying the wavelength on a wave. If you can't do that, go back to video number 2, which was labeling a wave. But you should be able to see that we could find the wavelength between here and here, or between here and here, so a peak to a peak or a trough to a trough. However, this wave doesn't start with the peak, so we can't start there, and it doesn't start with trough, so we can't start there. It starts here. It starts with a wave on this line of zero disturbance, so we've got to start there. I'm just going to draw these lines back in as best as I can. There we go. So missed another one. We've got to start here. So if we start here, we're going to looking for the next equivalent point. So we've got, I'm going to put my arrow on here. So we've got here up, that was going the opposite direction, and then back there. So we've got one wavelength here, one. So I'm just going to draw that there. So we've got one wavelength. And then we start again here. We're going to there. So we've got 2, here to here, 3, and here to here, 4. So this wave shows 4 full wave cycles, 4 wavelengths. Now, if we were told that this frozen wave diagram represents 1 second. So in 1 second, all of these waves would travel past this point. So there would be 4 complete waves in 1 second. So I'm going to say 1 second. It makes it very easy to find out the frequency, because the definition of frequency is the number of waves per second. And if we've got 1 second here, so to that very end of that wave, and we've got 4 wavelengths, so we've got 4 wavelengths in 1 second, then we know that it is 4. The frequency is 4, and the units are hertz, Hz, or you can write it hertz, like that. Okay, so I'll say that one more time, so that you just count the number of wavelengths. So you have to be able to identify them, and you just look at how many seconds that's taking course over. So in this case, 1. So there would be 4 waves in 1 second, which is a frequency of 4. Let's have a look. Let's change this. So let's say that there were still these 4 waves, but this was 2 seconds. So we've got 4 waves in 2 seconds. Now, the definition of frequency says the number of waves per second. So we don't want how many waves per 2 seconds, we want how many waves in 1. So what we're going to do is we're going to divide this to get it to 1 second. So in order to get 2 to 1 second, we're going to divide by 2, which is going to give us 1. And if we divide this side by 2, we're going to divide this side by 2. So 4 divided by 2 is 2. So if there are 4 waves in 2 seconds, there are 2 waves in 1 second. So we've got a frequency here of 2 Hertz. Okay. And one more time. Let's say that this wasn't 2 seconds. Let's say that this was 10 seconds. So we've got 4 wavelengths in 10 seconds. We're going to get this to 1 second. So we divide by 10. It's going to give us our 1 second. And we're going to divide this side by 10. 4 divided by 10 is 0.4. So we have 0.4 waves in 1 second. So we've got a frequency of 0.4 Hertz. So the final thing that I want to cover in this video is the relationship between the frequency and the wavelength. So I've just drawn 2 traces of frozen wave diagrams, both starting at the same thing. Both I've just put on the line of 0 disturbance, and we're saying that the energy is going from here, going that way, energy is going from here, going that way. And they are both covering the amount of waves that would pass from here to here in 1 second. So I'm going to do 2 waves, but of different wavelengths. So I'm going to draw this one first. And in this one, I'm just going to do another one. Okay, so we can see that in this first wave diagram, I have got 1 wavelength. So 1 complete wave cycle in 1 second. So I've got 1 wavelength in 1 second. So the frequency is 1 Hertz. In this one, I've got 1, 2, and 3. 3 waves in 1 second. So I've got a frequency of 3 Hertz. So we can see from these 2 diagrams that there is a definite relationship between the wavelength and the frequency. And the relationship is this: the longer the wavelength, the lower the frequency. Or the shorter the wavelength, the higher the frequency. To check your understanding, have a go at the questions on this slide. Just pause it and take however long you need.